Welcome guys. Welcome back to the second session of Pandas. We'll be continuing where we left off in the session yesterday, and I already have a data frame here. This data frame we used in the previous session, the yesterday's session, and I'll be like telling you some more data frame methods today, which will be useful for analysis of the data. And without any more delay, we can start. And I already have this. I already have imported. We'll just have to run this. I'll run that, and I'll also run this one. This should create a data frame, right? So we can see how the data frame looks. We have worked with this data frame yesterday, and I'll be working on this again and cover some of the left topics from yesterday which I could not cover due to time constraint. Okay, so we'll be talking about data frame methods, right? So one of the first method is index. So we can check what it does. So df.index, look here, the index starts from 0 and ends at 4, right? 0 1 2 3 4. Here you can see that start 0 and stop 5, and step is 1, so it is incremented by 1. Here total is 5, 1 2 3 4 5. So it starts at 0, and with an increment of 1, it counts up to, like, it has to go for it, the index are 5 in length, so that's why stop equal to 5. Alright, so here, so we can see the, this we can see this could give the value of the number of rows. We can also get the value of number of rows from this, like we can analyze that also. Okay, so next what we can do is we can see the column names. How to get the column names? We can just call the method df.columns, and here you can see all the names of the columns are these: the first score, second score, third score, and gender. Right, so here we can get the column names. Now another thing we can do is we can give the access, so we can get both of these value by using the access method. So we got the index, the output we got in index is here, and the output we got in columns is here. So by access method we can get both the index and columns, right? Now also we can check for unique values, so number of unique values. So what we can do is number of uniques. So number of uniques we can check. So here you can see first score has 4, second score has 4, third score has 4, and gender has 2. What does number of uniques mean? Like in first score it is 100, 90. Nan value is not counted because it's not unique, it's empty, so it's not a unique value. Nothing is present here, so it won't be like involved in any calculation or evaluation. All right, so the first different value is 100, second different value is 90, 95 is another different value, and 45 is another different value. So total 4 different values are present in this first score column. Similarly, in second score column also 1 2 3 4, 4 different values. In third score also 1 2 3 4, 4 different values. In gender column 2 different values are there, male and female. Right, so that's why we can get the number of unique values. All right, so first score has 4, second score has 4, third score has 4, and gender has 2 unique values. Now we can also like check for the value counts. Right, so let us see what is the count of male and females in this column. Right, so how can we achieve that? We can call the columns which we want to check for I want to check for gender. So df gender, we already know how this works in yesterday's session. So by giving the square braces and giving the name of the column, we can select that column. All right. So df gender, and we can here use the value counts. All right. So value counts. So this will give us the value of the different values in this. So one is male and the second one is female. So male have two values, like male is present 2 times and female is present 3 times. So that is what this value is giving us. So female 3, male 2. So the value counts. Alright, so this is how we can check for the value counts here. Okay, so what we can do next is, there is also a values method which will give all the values in the array format, numpy array. So here it is the same 100, all the values are given in this numpy array, right? So this is also present. Also we already saw this one is null function, is null method. We already know about it from yesterday. False, it will like check for the null value, and if it is null, then it will be true. If it is not null, then it will be false. So this is true because of this value is non value or null value. That's why it's a true, and this one is also true, this one is also true because of non values and non values here, right? So this is why these three are true and all the rest are false. So we can check for null values by is null method, right? So now we can also check the data types of the columns. So what are the data types of the columns, right? So what we can do is df.data types, right? So here you can see that first score is float, second score is also float, and third score is float, and gender is object, right? Object data type. It's not string, it's object data type, right? So keep in mind that, right? You have to keep that in mind, that it is object data type. This one, this column gender is an object data type. All the string, all the like categorical columns or categorical data columns are object data types in data frame or whenever using pandas, right? So now also what we can do is we can also sort these rows or columns. So let us learn how we can sort the values, right? So what if we want to, where is the data frame? Yeah, this is the data frame. Okay, let me print that again. df, yeah. So this is the data frame that we have, right? So what if we want to sort the values of the data frames, like the rows, according to ascending order of gender, right? So I want to sort it like that. So how can I achieve that? So what we can do is df.sort values, right? So df.sort values, and now what I want to sort, according to what I want to sort, I want to sort according to gender, right? And axis, what does axis mean? Like x is equal to 0, I'm giving x is equal to 0 means I want to sort the rows, okay? Sort the rows, and x is equal to 1 for columns. So here I want to sort the rows, I want to rearrange the rows or sort the rows according to the ascending order of the values of the gender column, okay? So that is why I'm giving axis 0. Axis 0 for, axis 0 is for that is x is equal to 0 for the like sorting the rows, right? And x is equal to 1 for sorting of columns. Okay, so I'm here sorting the rows according to the values of in present in the gender column. So x is equal to 0, and also I want to give in ascending order. So ascending is equal to true, okay? We can also, I don't want this to be permanent, that is the sorting, I don't want to be permanent, so I will give in place is equal to false. We already talked about it yesterday. This parameter we touched about it yesterday, we talked about it yesterday. So basically it means that the if the sorting will not be permanent, like it will show what is the result, but when I print the df again, it won't, it will be like this only. Okay, so the value won't be permanent. Okay, so I don't want it to be permanent because I want to do another I want to use other methods to it. But if you want that sorting to be permanent, you can give it in place equal to true. We already talked about it yesterday. Okay, now what we can do is we can also give the kind of sorting we want. I could give quick sort. Okay, this is not required, these parameters you can leave it, or you cannot give it, only the gender column is required, sorry, the column name is required, and the axis is compulsory. All right, other things are by default have some values. Ascending is by default. If you do not give this, then pre-default it is true, so the data will be, the rows will be sorted in ascending order only. Okay, in place is equal to false is also default, and also the for kind quick sort, and other thing we can give is NA position. What is NA position? NA position is the position of nan value. So in case if a nan value is there, right? If in case nan value is there, then what should be the position of that nan value? So I want it to be last or first. It could take two values, first or last. I want the nan values to be last. Here in this gender column, we don't have any nan value, so this parameter won't affect anything. But if we sort according to third score or second score or first score, because all these three columns have nan values, then this parameter will affect, and the nan value row, that is if we sort by the third score column, then this row, the zeroth row, the row with the zero index, have a nan value, so this will become last because I want the NA position to be last. So that is what this parameter does, that is NA value, NA position to be last or first. You can give first or you can give last. So since we are sorting here by the gender column, so it won't be affecting here, but yeah. So okay, so now we can check. Here you can see the columns, or the rows have been sorted according to the gender column, in values in the gender column, that is male and female. And since female, the F starts comes before M in the alphabet, so that is how the ascending order works. And in the females, the one with the lower index comes first, that is 1 3 4, and in males 0 2. All right, so it comes with the ascending order of index also. If the values are same, then it will go towards the index, check the index, the ascending order of index, and it will sort like that. All right, now what if we want to, like I was telling you, like for third score, how will this NA position affect? Let's see that. Okay, so df dot sort values, and I want the sorting by third score column. Give the column name. Okay, axis equal to 0 because I want to sort the rows. Ascending equal to true, I don't want to give because it is default value. In place equal to false, I could give. Let's give in place equal to false. I don't want to give kind, let it be default. Now NA position, I'll give NA position equal to last. So what this will do is, here the NA position is fourth, or first, second, third, fourth, fifth. Okay, first, second, third, fourth. Fourth value is NA value in third score column. So what this parameter will does is sort all the four values, because this is empty value. All right, so we cannot sort with, like, this doesn't have a value, so we need to do something about this value. So what we are doing with it, we are placing it at last. So NA position is at last, or if you want it at first, you can give first here. So let us give it as last and check what happens. So here you can see third score has been sorted by ascending order by default. We have not given the ascending order true, but it is by default. So 40, 50, 80, 89, and then nan, because we wanted the to be last. What if we give it as first? Then the nan value will become first. Okay, so this is how it works. Okay, now what else we can do is we can also like yeah, what else we can do is like this will, of course this will not like change the df will remain the same because I've given in place equal to false. So that if like the data frame remains the same. That was the, what was the data frame looking like? Here is the data frame, original data frame, and this is what it looks like. This is what it looks like right now. So it is same because we have given in place equal to false, and therefore it is the changes by sort values is not permanent. If you want to this value to be remain permanent, this data frame or the changed value to be remain permanent, you can give in place equal to true. Okay, so now what we can do next is, okay, one more thing, we can like sort index. Okay, so here the index is already sorted. Let us try to do something. Okay, let us like append a data frame and let's see what happens. Let us create a data frame, one more data frame. I'll first create a dictionary. Okay, why not we just copy the first data frame and edit that. Okay, so here it is. I'll call it as data2. I want the column names to be same. I'll give some values. I'll just give two values. Let it be two values. Let this column be 10 and 20. Let the second column be second score, having two values 30 and something 40. And let us give the third score also as 23 and 34. And the the fourth column also let us have male and female. Okay, so here we have a dictionary. Let us create the data frame df2, and we can create it by pd dot data frame. We can pass data2 here, and we can see the df2 by printing it. So here it looks how it looks. It also has index 0, 1. So now what if we append this small data frame into this data frame, the original df data frame? What if we append that? We have already tried it in the previous session. Now I'll try to append it again, and what we're going to do is sort the like the indexes. Let's see what happens first when we append it. So how can we append it? We can append it by df equal to df dot append. Alright, here we can give the df2. Okay, we want to save it in df only. We want to change the data frame df, and where we want to append it, we want to append it in df, and by which we want to append it, we want to append it by df2. Okay, so let us see. We have run that. Now see the value. We can print df. Here we can see 0 1 2 3 4 and again 0 1. So the indexes have here are random, or like it should be 0 1 2 3 4 5 6. No, but it's not here because we have appended it. So now we can see how sort indexes work. I did that. I did all this so that I can show you the function or the method sort index. Okay, so now sort index. Okay, so what we can do now is df dot sort index. This is the df. Now we can do is df dot sort index, and the parentheses, look, 0 0 1 1 2 3 4. The indexes have been sorted, but this still looks weird, right? We can't have indexes, two indexes having 0 0 and two indexes having 1 1. Okay, so what we can do is we can also do one more thing. What we can do is df dot reset index, right? Df dot reset index. So what this will do is reset the index here. Now it is all the data here is unaffected, but this index is now, right? So now this is the this index becomes correct, 0 1 2 3 4 5 6. Okay, now let's work with a bigger data. Let's talk about getting or reading data, CSV files, spreadsheets. Okay, okay, so let's see how we can do that. All right, now I have a data. Look, I'll show you the spreadsheet. Okay, yeah, I'll show you that first, and this is a spreadsheet. This is NBA spreadsheet, and this is how it looks. This is a very large data. Okay, and having a lot of columns and a lot of rows, and we'll be working on this, like seeing how we can work on large data set. For now we have been working on a data set of having 4 rows, 3 columns, or something like that, 4 5 rows, 4 5 columns. Now this is having very large number of data and very large number of columns and very large number of rows. Okay, so we'll be working on this. So let us try to first read this CSV file or spreadsheet file, CSV file comma separate file. Okay, so let us reading or getting the input or input. Okay, so how we can do that? I'm taking it in DF only. Okay, so we can do something like pd.read CSV file we are reading, pd.read underscore CSV. We have to give here the path of the CSV file. Okay, so we have to give the path of the CSV file. Here I have this Pandas 2 Python notebook, and the CSV file is in the same location. All right, so my path will be the same. So if you have any other path, you can provide that, or else you can save that CSV file to where your notebook file is, IPYNB file is, right? And so my path will be same, and va.csv uh, path address and path of the file and with the name of the file, so that is nba.csv. All right, now we can run this and we can see how it looks. Here it is. Okay, so this is having 1,26,314 rows and 23 columns. Okay, I'll provide you I'll obviously provide you the CSV files and all in the classroom or the GitHub, so you don't have to worry about it. Okay, so this is having 1,26,314 rows and 23 columns. Okay, now, but here you can see that we cannot view all the 1 lakh rows or all the 20. You can see here the dotted lines. One we can see up to 5th, 0 1 2 3 4, and after that it is dotted. And also here in the 23 columns up to this franchisee ID, franchise ID we can see, and after that it is dot 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 and rest and the last columns are there. Okay, so what if we want to view all of this data set here, like all of the values here, all of the columns, all of the rows here? So if we want to see all of the columns, what we can do is we can set option pd.set option, and here we can give display dot max dot columns. Okay, and also none. Okay, so this is the syntax, or this is how you can like display all the columns, displaying maximum columns, right? You can also give display.max.rows, but I will not recommend you because this is having 1 lakh rows, and displaying all the 1 lakh rows here will be very like untidy. Okay, so don't do that. But if you have smaller data set, say 1000 or 10,000, you can maybe try that, but don't do it with this data set because it is having uh, 1,26,000 rows. Okay, so for columns you can do, because it is having 23 columns, so we can view all the columns. Let us run this, and now we can again see the data frame. Here you can now see all of the columns. Okay, so this is all the 23 columns. This is a NBA data. Okay, and the season games are the date of the game, which the year at which the game was played, and the order, the LGID. This is the name of the franchise or the teams which play NBA. This is the ID of that teams. Okay, so this is how the data is given. All right, so we'll be working what we learned in smaller data sets, all these things and all the things which we learned yesterday, we will be applying, or will be applying some of it on this large data set. All right, so first there is also a thing called head, so that we can view, like what if like if we want to view the top 10 or top 20 or top n rows, we can do that. So if we want to view the top 10 rows, we can give the 10 value here to the head, and we can see the head 10, or we can say the top 10 values. Okay, so the first 10 values we can see here. Also, if you want, you can give 20, so it will show you 20 values, top 20 values, or first 20 values I could say. And there's also df.tail, and this is also similar. It will show you the tail values or the last values. So df.tail 10, and these are the last 10 values. Okay, now what we can do is we can also do the df.index. So it starts at 0, stops at 1,26,314, and the step is 1. Okay, incremented by 1. So this is the index. This is how the index is. You can also check all the columns, df.columns, df.columns. These are all the columns, the list of columns. Okay, we can do the df.access to see the in df.columns and df.index together. We can give the df.access. Also, there's another thing df.shape. It will give you the shape or the dimension. Okay, this is the number of rows. So this is the number of rows, and this is the number of 23 is the number of columns. So this is how the this is what the df.shape does. It gives us the shape of the data set. Also, what we can do is get the size of the data set, df.size. So this is like 29 lakh, yeah, 29 lakh 5,222. So what is this value? This is just the all the values here. So what will be the all the values? It will be just the multiplication of these values. You can check here. So I'll just copy this, print it, copy paste it here, and multiply, and this should be same. Yeah, so this is same. So these are the total values in the data frame. So these are the in the total data set there are 29 lakh and something values. Okay, also we can check the dimension. The dimension meaning if it is 1D, one dimensional, two dimensional, three dimensional, it is obviously having rows and columns. So this is two dimensional. We can check it by ndim, and you can see it is two dimensional obviously. There's also thing called describe. Okay, this will give you a detailed information about the columns, the numerical columns already. So not the categorical or string or object columns it won't give. It will for numerical columns give the count, okay, mean, standard deviation, minimum value, and rest of the values. Okay, so these are the some of the information which you can get from df.describe. Okay, and what we can do next is we can check the data types also of the columns. So this is the data type. The game order is int. You can see what is game order. So these are obviously int values, 65, 135. These are not float. These are not object. These are int values. So game ID is object because it must be having categorical data or string data. Yeah, it is having 205, 201506. It is having numbers and letters, characters together. So it is obviously like object data type here, and similarly you can check for rest of the things. And similarly if you want you can do that, but it won't make a sense here. Df.values, you can't see all the values here of course, but it will be in numpy, sorry, a numpy array format. Okay, so what we can do next is check for the unique values also. Let us check for unique values and uniques. We all this we tried on the smaller dataset, but we are trying again on the larger dataset to see how it works. So you can see here that game order has 63,157 unique data. Game ID has similar 63. LGID has two unique data. Is copy has two unique data, and what we can see is franchisee. Okay, where is franchisee? Okay, which one is franchisee? Let us see. Yeah, this is franchisee ID, right? Name of the teams: Huskies, Knicks, Stags, Knicks, Falcons. All these are the NBA teams. All these must be NBA teams, and it is in Fran ID column. So the different teams are, how many different teams are there? So 53 different teams are there. Okay, so this is how you can read the data and analyze the data using pandas and using different methods in the data frames. Okay, now let us also check what are all the, let us try to check what are all the teams in this excuse me, let us check what are all the teams in this column. Okay, I want to see what are the teams in this and what is the count of it. So you can get the value counts. Let us try that. So I want the df, I want it for fran id, and what I want is value count. Okay, let us check. So Lakers have been mentioned, or Lakers have been mentioned here uh, most of the time, 6,000 times in this fran id. Okay, yeah, so 6,000 mostly the Lakers have been mentioned. After that, Celtics, Knicks, Warriors. These are the number of times this letter, or sorry, this string or this team has been mentioned, or this is been present in the fran id column. So this is the value count. So this is how you can check or analyze whatever your need for the data set is. Okay, so what else we can do? We can sort the values. Let us first print the df so that we don't have to scroll it too much, and we can see it here only. Let us print it again. Yeah, so let us sort the values. So how can we sort it? Let's sort it with the ascending order of the teams. Okay, fran id. So let us sort it. sort values by fran id column. Okay, ascending will be true only by default, so I'm not giving that. Axis is compulsory, so I'll give that. And 0 for rows, we want to obviously uh, like sort the rows only, of course. And in place I could give false. I don't want to make it permanent, that is why. And I don't want the sorting to be permanent, that is why. And I can leave the rest. Also, if there are any nan values, let us give na value, sorry, like we can, like if we can check for the na values, all right. You can also check for the na values by dot is null function. Here we have checked for it. Like I'll show you. Somewhere I must have checked. Yeah, df dot is null. We can like this. We can also check that. But if there are any, we'll just provide this argument or this. So if there are any, we'll just sort them to the last position. Okay, so just give na position as last. Okay, so this has been sorted. The index will always obviously be like mixed, because the first, like the in ascending order, this Baltimore team is the first one, and the data has been like sorted according to this prime ID column, or the name of the team's column. Okay, so this is how we can do that. Now what if we want to reset the index? We can do like reset index. This is how we can reset the index. And firstly, let us give it true. Let us make it permanent. Yeah, let's make this change. Let's make this sorting permanent. Okay, now let us see how it looks. Print the df. Yeah, you can see here it is permanent. Now we can reset the index similarly, in the similar way which we did earlier. Okay, and this index has been resetted. Okay, so I'll also show you one more data set. Okay, I have shown it to you, this NVA short data set. I'll be also working on that. Okay, so first let us see how to, like we have sorted it. Let us suppose you did what you wanted to do with the data set, and you want to convert this data frame back to the CSV file, so that you can share it, or you can like use in the Excel, like you want to like convert it back to CSV file and view it as spreadsheet. Okay, so what you can do is output it, or like we can say is CSV to CSV from, convert CSV from data frame. CSV from data frame, how can we achieve that? So what we can do is we can give to CSV df.toCSV, whatever data frame we want to like convert into CSV, df.toCSV. Okay, and just give the name of the whatever file name you want. So let us give a, I'm just giving, or you can give sorted nba.csv. Okay, something like this. You can give anything you want. And index equal to false you can give, so that in the CSV file we don't get another index. Okay, and okay, now we can just run this. Okay, now there must be a sorted nba.csv file being created. You can check. Yeah, here it is, sorted nba.csv been modified or created. seconds ago, having a size of 17.9 MB. Alright, so if you want, you can open it and check. Alright, let us now work on another data set. I want to show you how, to show you another data set. So let's try another data set. Okay, I'll not name it as DF because we already have named so many data frames as DF. Let us give it dataset this time. So dataset, and we will read similarly what we did for the nba.csv. We will do the same for nba. We want this time we want to like this one, nba short. If you want, you can open it. Let us try to open it. Okay, so this is how the raw file of the CSV file looks. These are comma separated values. This is why it has the name of CSV. I can also open it in spreadsheet if you want to look at it. Okay, let us close this one. We don't want to save this. And let us open the short one, which will be working now. Let us open that and see how it looks. Okay, so this is the nbs short, and we'll be working on this now. Okay, so this is a relatively short data set. Okay, so we'll be working on this now and see what we can do. Okay, so this is how it looks in the spreadsheet. All right, and this is how it looks in raw format, because it is comma separated values. You can see name, comma teen, comma number. So this is why hence the name .csv file, right? Okay, so we'll now read the file. What is the name of the file? We can close this and see what is the name of the file. So this is nba short.csv, and if you have the file somewhere else in some other directory, you can either paste it with the you can either paste it in the same directory as this pandas 2 file or any other file you are working in, or alternatively you can provide the full path of the CSV file. Anything you can do. Okay, so this is how we will read it, and just run this. Okay, something is wrong. Okay, and we are not it should be underscore, not dot. Okay, so this should work now. Now we can see the data set. Yeah, so this is our data set. We can check the shape. Let us check the shape of this data set. Okay, df dot shape. Okay, so it is not callable. Yeah, don't give the parenthesis. Df dot shape. So here we have, okay, sorry, this doesn't have the name df. We are working with dataset. We have given the name dataset. So this is dataset. This value is for the previous dataset we were working on. This was named as df. This is named as dataset. So keep in mind the small mistakes. Dataset dot shape. Okay, another spelling mistake. Dataset. Yeah, finally. Whew. Dataset dot shape. Alright, so now we can do that. We can also check the head if you want to see 20 first 20 rows. You can see the last 20 rows. Excuse me. Okay, last 20 rows. Yeah, right. And similar things you can do, but also one more thing we can do here is give info. This is also there, Might not be of much use, but yeah, it's there. You can gather some information about it. Let us do all the things, all the methods we have learned up till now and apply it here. Dataset.access, the name of the index, start from 0 and stops at 458, step of 1, index all the column names, right? So all this we can also describe it like we did earlier. Dataset.describe. Let us hope we didn't make any spelling mistake. Yeah. Now let us sort, or we have already sorted. Let's not sort it. Okay, so let us get the value counts of the, let us see the first, let us first see the data set and then see what we can do with this one. So these are the team names of the NBA teams. Let us get the name of the teams. Okay, so data set, what is the team? Name of the column is team. Okay, so now we can do is dot value counts. So this will give us the value counts. So New Orleans Pelicans have 19 mentions, or 19 times they are in this row. Similarly for all that. Now, what if, like, we want to see all the, let us say, yeah, let us say Orlando Magic. What if we want to see all the rows that have Orlando Magic in the team columns? Right? What I mean is that Orlando Magic, all the rows, I want to get all the rows which have Orlando Magic in the team column. So how can we achieve that? What we can do is use the lock, which we have already studied or learned yesterday. So we'll be using that, and what we are going to do is dataset.lock, and here we will give like this, and this is how. What we want to do is, we want all that, we are selecting the data set first, we are selecting the column. So this is, we are selecting team column, and what we want is, we want all these which are having the name Orlando Magic. Select in the column team, select all those which have the name, which have the value Orlando Magic. Orlando Magic is here. Okay, so select all the values having in the column team, select all the yeah, select all the values having Orlando Magic, and we can print that. Let us see, there are total 14, and we get 14 rows which are having the name, or which are having the team as Orlando Magic. So in the team, the value is must be Orlando Magic, and we are returning that, we are printing that. Okay, so this is how you can do that. You can do all sort of stuffs here. So now we can also print the, let us try to print the weight of all these players. So these are the name of the players, obviously, which are playing for this team Orlando Magic. Alright, so let us try to print the weight of all the players which are playing for Orlando Magic. You get my point? Okay, let me comment that. Okay, so what I am trying to do is getting the weight, weights of all, weight of all players, all Orlando Magic players. Alright, so how we can achieve that? So we will do the same thing here. We'll first select those rows, dataset.lock, and here what we want is dataset call dot t, sorry, in quotes team. Yeah, select the rows team, select the team row, select the column team. Okay, which are having the values Orlando Magic. Same thing which we did here. We are selecting all the rows which are having Orlando Magic value in the column team. Okay, we are doing the same thing. Now what we can do is, what we want is the weight. All right, so what we can give here is weight. Okay, so you can see the weights of those players, Orlando Magic players, is printed, so you can access that. If you want height, you can give height. You can, if you want age, you can give age. You can, if you want position, number, anything you want, you can get. If you want name, you can also get that. All right, so this is how you can confirm it. 245, 205, 220, all these are the values of the weight of all Orlando Magic players. So this is how you can like select, you can change, or you can do everything like manipulation, analysis of any data set, and do all kind of stuffs with using pandas. So I'll be wrapping up today's video of pandas, session 2 of pandas. Okay, so this is me, Ankit, and I'll be signing off for today.